For any triangle ABC, we need to show that the product of A plus B plus C and the sum of tangent of A over 2 and tangent of B over 2, that equals to 2 times cotangent of C over 2. So here we have the half angle formula, tangent of A over 2, tangent of B over 2 and tangent of C over 2 we'll be using here. Now here we have few terms that are being used here. We have the S, we have A, B, C. Let's try to understand what that means. Let's say we have a triangle A, B, C. The sides opposite to angle A, angle B and angle C are going to be represented by the letters A, B and C respectively in lowercase. If we take the sum of this side, A plus B plus C, and that's going to give us the perimeter of the triangle, and if we divide this perimeter with 2, then that gives us the semi-perimeter, and that semi-perimeter is denoted by the letter S in lowercase. So here we will start our proof from the left side. So here it's given we have the product of A plus B plus C and tangent of A over 2 added to tangent of B over 2. Now in place of A plus B plus C, we can replace this with 2 times the semi-perimeter of the triangle, so that's S. And then in place of tangent of A over 2, we're going to use the formula. So here we have the square root of S minus B multiplied to S minus C divided by S multiplied to S minus A added to tangent of B over 2. So tangent of B over 2, that's given by square root of S minus A multiplied to S minus C divided by S multiplied to S minus B. Fine. That will be equals to 2 times S. So let's combine the two terms within the parentheses. So here we have the common denominator given by square root of S multiplied to S minus A times S minus B. Then in the numerator, we have square root of S minus C multiplied to S minus B added to, so here we have square root of S minus C multiplied to S minus A. Fine. Now we can factor out square root of S minus C from the numerator. So we get 2 times S multiplied to square root of S minus C whole divided by square root of S times S minus A times S minus B. This will get multiplied to S minus B added to S minus A. Fine. Now what we'll do? We're going to take this S inside the square root. This is going to give us 2 times the square root of S squared multiplied to S minus C divided by the square root of S multiplied to S minus A times S minus B. Now S minus B plus S minus A, that's simply 2 times S minus A minus B. Fine. Furthermore, we can now combine the two square roots in the numerator and the denominator, so that we get 2 times the square root of S times S minus C divided by S minus A multiplied to S minus B. This will get multiplied to, now let's try to understand what's 2S minus A minus A minus B. So 2S, that's given by A plus B plus C. Now if we subtract A and B from both sides, that will be equals to C. That means 2S minus A minus B, that's equals to C. So here we have C multiplied to it. Now we get 2 times C. Now what is this? This is simply, if we go to our value for tangent of C over 2, if we take its reciprocal of tangent of C over 2, that's going to give us the cotangent function. So we have cotangent of C over 2. This will be equals to the square root of, so the denominator will become the numerator and the numerator will become the denominator. In other words, we are saying that this is simply cotangent of C over 2, which is the expression on the right hand side. So we have successfully proved our problem. That means the product of A plus B plus C and tangent of A over 2 plus tangent of B over 2, that's 2 times cotangent of C over 2. There's a C missing here. That's C also present, hence proved.